Hello and welcome to a video on energy dissipation, where we're going to be discussing what energy dissipation is and how it is useful in our lives. So first of all, there's your title, what is energy dissipation? And the keyword is dissipate, which means to waste, to throw away. So in this example, we're going to be talking a lot about cars, because everyone knows what a car is and have been in one, we understand it to a certain degree, and it's easy to talk about. So when we have a car, we put petrol or diesel in for the purpose of moving a car forward. Moving or kinetic energy. So this is the purpose of petrol in a car, is to move the car forward. That is the primary purpose of a car. Now, that's not the only thing a car does. A car often gets quite hot. If you ever put your hand, if you lift up the bonnet and you put your hand near the engine, you can feel the heat coming off. And heat, or thermal energy, is unwanted energy. And this will link to what we call wasted. I prefer saying unwanted because we don't technically waste energy, as we learned in one of the other lessons. We just have unwanted. It's not desired. We don't want the car to get very hot. The same as a mobile phone. You don't want a mobile phone to get overly hot. It doesn't work as well. So what we want, this is our wanted energy, and thermal or heat is our unwanted energy. So the more energy that's turned from petrol into kinetic energy, the better the efficiency of a car. And I'll go into efficiency in a bit more detail. But the more we have thermal energy, the less efficient a car is, because more energy is unwanted. We waste that energy. We don't use it to a good use. Now, a good example of this is a bouncy ball. A bouncy ball, if you drop it from, let's say, this height to the ground here, at first it will go down and then it will bounce back up to about this height, and then it'll go back down and it'll bounce up to about this height. What's happening here is energy is being wasted until the ball finally stays flat on the ground. Each time it bounces, it loses energy upon bouncing, and that's what we call unwanted, dissipated energy. Now, let's talk about efficiency, or let's talk about a light bulb. Another good example is a light bulb. So we have a light bulb. So with a light bulb, we've got a little bit inside, which is the filament, and that's what generally gives them. Now there's different types of light bulbs that come out, but this thing will have, it's a wire, and energy is passed through and it gets very bright. Now, our useful energy is light, and our wasted or unwanted energy is heat, thermal energy. We do not want it. You don't want a light bulb to get overly hot. You want it to give out light, but you don't want it to get too warm. If it's very warm, it won't work very properly. So this is another example of energy dissipation with useful and unwanted energy. So next time you're looking at an appliance like a kettle or a toaster, think about what is the useful energy and what is the unwanted energy. And that's important because the more useful energy we produce, the more efficient it is. The more unwanted energy we produce, the less efficient it is. Now, in efficiency, we need an equation, and you must make sure you remember this equation. So, efficiency, and this is as a percentage 100% is the maximum, so that's the most efficient. That's where all energy is useful. Very few appliances are ever 100% efficient, but the closer we get to that number, the better. Now we've got the equation. So useful energy output divided by energy input times 100. So this is the equation we're showing. Now useful energy output is the energy we want. So in this example up here, it is the light. So that is how much energy is being output is the form of light. Our energy input is how much energy we're putting into the bulb before it gets turned into the different forms of energy. So that would be both of these combined together would be the energy input. So for this example, let's say 100 joules is input into the bulb. 40 joules is converted to light. So we've now got our useful energy being 40, our total energy, our energy input being 100. We'll put this together and we'll have 40 divided by 100 times 100. Now this one's quite straightforward. We'll get an energy efficiency of about, change different colour, 40%. That's not very efficient. That's quite low. We should probably be aiming for 75% plus for good efficiency. So this one, not very good bulb. We should invest in more. So this is a way of going through the energy input, the energy output, and figuring out the efficiency. So next time you're looking at different appliances and things, just think, how efficient is it? How much energy is given up? Now, you won't be able to do these equations while standing in your kitchen. You haven't got the information to hand, but it's just something to think about. Now, final note, when someone says saving energy, this is not strictly correct. You need to be mindful of this. What we mean is that we aren't producing wasted, unwanted energy. So saving energy is just all about having the maximum efficiency and not using energy when it's not required. Okay, thank you very much for listening.